Hello, everybody. Today we're going to begin discussing Chapter 2, Section 6. And what Section 6 deals with is combinations of functions, and more specifically, how to compose them. Now, I believe that you learned this a little bit last year, although I'm not going to assume that you did. I am going to teach this as if this is the first time that you've learned this. So, the first types of compositions that we're going to talk about are arithmetic compositions, which are adding, subtracting, multiplying, and dividing functions. As you can see in this box right here, this basically explains it as to what we do. So if you see an expression where it says f plus g of x, what they're telling you to do is to take your function f of x and add it to g of x, which means you're going to add up all the like terms. Everything that can combine will be combined, and everything else will stay separate if it can't combine with any other like terms. And the subtraction is done in a similar fashion. You would have f minus g of x would equal f of x minus g of x. Now, one thing to keep in mind, if g of x had multiple terms, you would want to put that in parentheses, and you would want to distribute the negative to everything that is inside of those parentheses, so you are correctly subtracting everything. Multiplication can be easier. It could be a little more difficult. It really depends on how many terms each function f and g have. You might get into doing a good bit of foiling with those. I would say the easiest out of all of them is the division, because for the most part, for most of the problems, division, you will just take the f function and you will divide it. You'll put it in a fraction over the g function, and that'll usually be about it. You do have to specify what restrictions you need to put on that function by setting the bottom equal to 0 and then solving, but that shouldn't be too much of a problem. So let's take a look at an example problem here. So this says, let f of x be 2x minus 3 and g of x be x squared minus 1. And they want you to find the sum, the difference, the product, and the quotient. So they're telling us to add, subtract, multiply, and divide both of those functions. So we will do each of those. I'm going to go ahead and get my pen color to blue. So when I do f plus g of x, that means I'm going to take 2x minus 3 and I'm going to add x squared minus 1. And since it's addition, you really can just drop the parentheses there and just add up your like terms. There is only one x squared, so we're going to leave that one alone. And there is only one x term, so there's a 2x. And then we have negative 3 plus negative 1, which becomes negative 4. And so what you can see there, that our combined function f plus g of x turns out to be x squared plus 2x minus 4. Now, the next one, they asked us to find the difference. So it's going to be done in a very similar fashion. Really, the only difference here is that we are going to subtract instead of add. So I am going to set the problem up pretty much the same. We want f minus g of x, and that is going to equal 2x minus 3, but then we got to put a subtraction. And this is why it's important that you see that I'm using parentheses when I first initially set this problem up, because this minus is going to have to distribute to both of the terms that are in g of x. So f of x minus g of x becomes 2x minus 3 minus x squared plus 1. From there, we're going to rearrange to put it in standard form and then combine our like terms. So we have negative x squared, and then plus 2x, and then minus 2, because negative 3 plus 1 is negative 2. And there is our difference. So we found the sum, we found the difference. Now we need to find the product, which would be f times g of x. Now this one's going to be not too bad. These can get quite messy. But this one isn't bad at all, because we're just multiplying the two functions together, and each function only has two terms within the function. So it's not going to be that bad of a foiling problem. You've probably done hundreds of these over the course of Algebra 2 and Algebra 3. So we're going to do 2x times x squared, which gives me 2x to the third. And then we're going to do 2x times negative 1, which is negative 2x. The next thing we're going to do is negative 3 times x squared, which is negative 3x squared, and then negative 3 times negative 1, which is positive 3. So we foiled those two terms together. The last thing to do is to combine any like terms that we might have and then put it in standard form. And if you look, there's actually no like terms in this one. The highest power is 2x to the third, followed by negative 3x squared, and then minus 2x, and then plus 3. So there's our final answer after we foiled and then didn't have any like terms to combine. Sometimes you will, and then put it in standard form. Now, the last part of this is the quotient. And like I said, that's usually the easiest one to do simply because it's just more of a formatting. You're simply going to take f of x, which is 2x minus 3, and you're going to divide it by g of x, which is x squared minus 1. And once you have that division, you're pretty much done setting the problem up. Now, you do have to write the restriction. This is important because x squared minus 1 is not allowed to be 0. So that means x squared is not allowed to be 1, which means x is not allowed to be plus or minus 1. So you do need to write that restriction for the quotient. But other than that, it's pretty simple. So it says the domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. In the case of the quotient f divided by g of x, there is further restriction that g of x cannot equal 0. And that's what I just showed you, that you do need to list that when you do the quotient. So this says given that f of x equals 2x plus 1 and g of x equals x squared plus 2x plus 1, find the sum, the difference, the product, and the quotient. So we're going to do pretty much the same thing, and it looks like I accidentally didn't get rid of those two terms, so we'll have to work around those. But as we work those, we're going to do the exact same thing as we did in the last one. So we have f plus g of x, and that is going to be 2x plus 1 plus x squared plus 2x minus 1. The like terms here are going to be the x terms and then the constants. So the x squared is a standalone, and we have 2x plus 2x, which is 4x, and then 1 plus negative 1, which is 0. So there's our final answer for the sum. It's just x squared plus 4x. Now for the difference, it's really going to be pretty much the same thing, except we're going to replace the plus with a minus. So we have 2x plus 1 minus x squared minus or plus 2x minus 1. Now this negative has to be distributed to all three things. So we have 2x plus 1 minus x squared minus 2x plus 1, like that. Now we have like terms that we need to combine and then put things in standard form. So the x squared is the biggest term, so we're going to list that first. And then we have a 2x and a minus 2x, so that's 0. Those cancel out, but we still have a 1 plus 1, so that turns into plus 2. And once we have that, there is our final answer for the difference. The next thing to do would be the product, which is to multiply f times g of x, and that is 2x plus 1 times x squared plus 2x minus 1. So we do have a little bit more foiling to do than we did in the last problem. This 2x has to get distributed to each one of these terms like that. And then the 1 needs to be distributed to each one of the terms like that. So as I do that, 2x times x squared is 2x to the third. The 2x times 2x is 4x squared. And then 2x times negative 1 is negative 2x. Then I have 1 times x squared, which is x squared. 1 times 2x, which is 2x. And then 1 times negative 1, which is negative 1. So now that we've foiled everything, we just need to put our like terms together and we'll have our solution. So look for the highest power. The highest power first is 2x to the third. We do have two squareds. So we have a 4x squared and an x squared, which gives me 5x squared. The next thing after that is we have a negative 2x and a positive 2x. So those cancel each other out, and we are left with a minus 1. And so there is our final answer of our product. The last one to do is going to be the quotient. And as I said before, the quotient is easy enough to set up because you just simply take the f of x and you put it over the g of x, and you're done. Now, the setup of the problem is easy, but you do have to figure out what x is not allowed to be. So you've got to set the bottom equal to 0, or not equal to 0 in this case, and then solve it. Now, this one is going to be solved by factoring. Oh, I lied. This one is not going to be solved by factoring. We would need two numbers that would multiply to give us -1, but add to give us +2, and that is not possible to factor that. So the alternative to solving a quadratic equation by factoring is to use the quadratic formula. So we're going to have to do that. -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So it would be -2 plus or minus the square root of 4 plus 4 over 2, which gives me -2 plus or minus the square root of 8 over 2. We're almost there, and I'm running out of room. The 8 would simplify. I'm going to do this up. I'm going to go up to here. I'm going to go back up to here. The 8 would simplify, and a 2 would come out because 8 is 4 times 2, and the square root of 4 is 2. So this would become -2 plus or minus 2 square root of 2 over 2. Now, the reason why I wanted to do that, you can see the 2 on the bottom is going to cancel this 2 and this 2. So the final answer is -1 plus or minus square root of 2. So that means x cannot be -1 plus or minus the square root of 2. So what you can see in that problem is the setup for the quotient was really easy, and the hard part was finding what x was not allowed to be. You have to list that for the quotient one. If you don't list that, you will miss points because it is a part of the problem. All right. So that's what I wanted to show you today. So as always, if you have any questions, feel free to email me. Have a great day.